Light-emitting diode LED is a semiconductor device through which light is emitted by passing electric current through it. LEDs are more lasting and energy-saving compared to the conventional incandescent bulbs as they are not powered by heat to illuminate. The produced light is achieved through the recombination of electrons in the semiconductor with electron holes and a release of energy in the forms of photons, a phenomenon called electroluminescence. The energy bandgap of materials in LED will determine the color of the light. LEDs find numerous applications in the electronic gadget, display screens, illumination, road signs, automobile lighting, and even a medical equipment because this is small and low power consuming and very low and capable of quick switching.
Now I'm going to explain about working principle. Firstly, semiconductor material. LEDs are made from special semiconductor materials like gallium arsenide (GaAs) or gallium nitride (GaN). These materials emit photons when energized. Secondly, PN junction. LEDs have a PN junction where P type is positive and N type is negative. Semiconductor layers meet. This junction is crucial for light generation. Thirdly, electron and hole movement. When voltage is applied, electrons from the N type material move toward the P type material where holes positive charge carriers are located. And then energy air release, which is called electroluminescence. As electrons recombine with holes at the junction, they release energy as photons light. The emitted light's wavelength depends on the semiconductor materials. And the final is the color of light. The LED's color is determined by its semiconductor materials composition. For example, red and yellow is gallium arsenide phosphide, which is called as GaSP. And then green is a gallium phosphide, which is GaP. And then blue and white is a gallium nitride, which is called as GaN.
Good day, madam. My name is Priscilla. So I'm here to present the advantages of LED. First and foremost, LED light is energy efficiency, which is LED is more energy efficient and it's consume less amount of electricity to produce the same amount of light. So the energy bill will be lesser and it's convert to smaller carbon footprints. Secondly, the longevity. The lifespan of LED is long lasting than other bulbs, so this will reduce the replacement frequency and it's also reduce or save our time and money. Next, the durability of LED. LED is more resistant to shock and vibrations compared to other bulbs, which makes them suitable for other applications. And then the compact size. LED light is small and versatile, which helps us to allow for creative design and integration into various lighting fixtures. And then LED light also have an application which is instant off and on, and it will be instantly on and off without any delay. And other than that, it's also have color options which there are wide ranges of colors are available for LED, which offers a greater designs. And then dim ability, which is many LED lights are dimmable, which enables in precise control over the light intensity. And lastly, environmental friendliness, which is LED light doesn't contain any mercury, so it's more environmentally friendly than other bulbs. That's all from me. Thank you.
Okay, next we see about the disadvantage of the LED. So for the first is high SZ, which is the blue light exposed. So LED, especially blue and white ones, emit the high intensity of the light. So this kind of the light can cause the high strain, fatigues, and over the times even retina also damage. So this kind is very especially risk in tools like microscopes or scanners where users are looking toward light source very closely. So without the proper filters or safety covers, users might get exposed to unsafe light levels, which is many users are does not even though realize it. So next is we have the problem of the heat build up, which is even though the LEDs are known to be the energy eventually, they still generate the heat when we use for the long periods. So in the compact of the instruments like a small optical sensors, this cannot escape easily. So if not managed properly, it can lead to the thermal damage, reduce the LED lifespans, or even can cause the instrument to fail. So that's why the proper cooling mechanisms are very important in this system. So for the third one is the expensive or high presences of the LED. Actually, LEDs are very cheap, but the ones used in the optical instruments need to be high presences. That means they must give off very specific color or wavelengths, be extremely stable, and avoiding the flickerings, even after long uses also. So because of the strict requirements, these LEDs are more expensive, which is increase the overall the cost of the equipments. And then the last one is LEDs are very sensitive to the electrical conditions, which is there are voltage spikes or unstable power supplies. The LED might get the damage or give off unwanted brightness. So this can cause the light pollutions, which may affect the nearby the instruments or even disturb the environments. So especially in the outdoors or wildlife optical studies. So it can also distract the users or reduce the accuracy of the optical systems. So even though the LEDs are widely used in a model optical instruments, it's still important to understand about the disadvantage, especially when the safety, accuracies, and long-term use are very important. So these are the disadvantages of the LEDs.
Types of LED. First, drop on LED. Found in different shape and size. The most common LED are 3mm, 5mm, and 8mm. Available in different colors like red, blue, yellow, green, and white. Second, bi-color LED. Can transmit two colors, a free lead in which two anode and one is a common cathode. Depending on the order of the lead, the color will be formed. Number 3 is high power LED. Emit a high level of brightness, as in automotive lighting, straight lines, and industry application. Fourth is organic LED, as organic compound that emit light when electricity is applied, as in smartphone screen, flexible display.
We look at application of LED technology. LEDs are widely used due to their versatility, low energy consumption, and compact size. They are the major areas where LED play a vital role. First is general and industrial lighting. For an example, residential, commercial, and street lighting. For an example, ceiling lights, office light, energy efficient LED street lamps. Second is display technology, which is television and monitors, smartphone and tablets, and billboards, and signage, which is outdoor digital boards or high definition energy saving LED screens. Third is automotive, which is headlights and taillights, and interior lighting, safety feature such as daytime running lights, dashboard, ambience light. And we look at fourth one is medical field, which is surgical lighting, phototherapy, dental equipment such as LED curing lights, treating skin disease like acne and deodorant in newborns, and lastly bright and focused cool temperature lights. And for agriculture, indoor farming and greenhouse such as stimulates natural sunlight or year-round crop production.
Innovation of LED. First, quantum dot LED, as in eye and TV screen, and provide more vibrant color and ideal brightness. Flexible and transparent LED, as in smart card, foldable phone, and transparent display. UVC LED for disinfection, emit ultraviolet light to kill bacteria and virus. And lastly, smart LED, Wi-Fi or Bluetooth enabled, can be controlled via smartphone, integrated with smart home system.
In conclusion, LEDs have revolutionized the field of lighting and electronics with their numerous advantages over traditional lighting sources. They are highly energy efficient, have a long lifespan, offer superior durability, and are environmental friendly. Due to their small size and low power consumption, LEDs are widely used in various applications including residential and commercial lighting, display technology, automotive system, and consumer electronics. In conclusion, LEDs represent a significant advancement in lighting technology, offering a sustainable and cost-effective alternative to incandescent and fluorescent lights. As innovation continues, LEDs are expected to play an even more greater role in energy conservation and the development of smart, efficient lighting system.